Okay, welcome America, India, and Taylor Swift. Today I'm going to review the first type of special right triangle, okay? So this whole unit is on right triangles. And the first lesson we did was on Pythagorean theorem. If you're given two sides and you're asked to find the third side, you can use Pythagorean theorem to find it. If it's a special right triangle, if you notice that the relationship of the angles, if it's a 45, 45, 90 triangle, we have a shortcut that we can use to find the length of the missing side or sides. So the first thing we notice is most of the time they only give us one of these 45s, okay? Most of the time they'll just give us that 45 and that's 90. But that tells us this is a 45, 45, 90 triangle because sum of all the interior angles in any triangle adds up to 180 degrees. So this one has to be 45. Are you with me? Okay, now, the base angles theorem, back from a previous unit, and unfortunately you're just gonna have to start remembering all the stuff I've taught you. It kind of just builds, okay? But the base angles theorem says if these base angles are the same, the sides opposite them are also the same, which makes these legs same length, okay? So if you're given one, you know what the other one is. And then the relationship between the length of the legs and the hypotenuse is times the square root of 2. So if they give us this length as 8, this length would be 8 root 2. This length would also be 8. Okay. Where it gets tricky is when they give you the hypotenuse and ask you to find the length of the leg. You have to go the opposite direction. From the leg to the hypotenuse, you're multiplying by the square root of 2. So the opposite operation is dividing by the square root of 2. And sometimes you end up having to rationalize the denominator. We're about to do practice, problem math. So go to slide number 16, okay? Number 16 gives us a right triangle and gives us the lengths of the legs as the same, which tells us that the base angles are also the same, which makes them each 45 degrees. Is everybody okay with that? Because 45 plus 90 adds up to 180, yes? Okay. So, because that's 90, and these are the same, each of these have to be 45 degrees. Because 45 plus 45 plus 90 adds up to 180. Are you good with it now? Sure. Okay, so now, we got a whole bunch of extra marks here. That's okay. That's better. Okay. So the length of the leg times the square root of 2 is what you'll have to memorize to get the length of the hypotenuse. 7 root 2. Done. Now you can use the Pythagorean theorem to find the length of the hypotenuse, but this is a shortcut and it's the foundation of trigonometry, which is basically half the year of pre-calculus. So you will see it again, but not for another year. Any questions on why the hypotenuse is 7 root 2? You just have to memorize you're multiplying by the square root of 2. Okay, more difficult type of these problems is when you are given the hypotenuse, like in slide number 17. Slide number 17, we have a 90-degree angle, we have a 45-degree angle, which makes this a 45, 45, 90 triangle, which means it's special. That tells us the relationship between the length of the legs, which by the way are the same, and the hypotenuse is times the square root of 2. And we're gonna have to go the other direction. We're gonna have to divide by the square root of 2 to get the length of the leg because we're given the hypotenuse. So 4 divided by the square root of 2, we can't leave this way. We're gonna have to rationalize the denominator. It's been a bit since we've done this, and let me show you again, and you're gonna be like, oh yeah, I kind of remember that. We have to multiply by special 1. 4 times root 2 is 4 root 2, and root 2 times root 2 is just 2, because the square root of 2 times the square root of 2 is 4, or square root of 4, right? Square root of 4 is 2. Is everybody okay with that? It's been a few months since we've rationalized the denominator. I think that was the beginning of unit 5 I did that, and now we're in unit 7. Now we're almost done because we can simplify this. 2 goes into 2 once, 2 goes into 4 twice. So the length of these sides is 2 root 2. How are we doing? Okay, this is the hardest type of example for a 45, 45, 90 triangle, where you have to divide by the square root of 2, rationalize the denominator, and then simplify at the end. That's as hard as it's gonna get. We good? All right, I'm gonna move on to the other type. Let me start a new video.